Anusha, can you tell me?
Yes, ma'am. Yesterday, we initially first were trying to draw the binary tree for the RBDD using Shannon's expansion. And then we learned how to do the reduced algorithm, how to draw the binary tree, reduced binary tree for the using reduced algorithm, ma'am.
Okay. So students, please remember, for any given Boolean expression, you can draw the binary decision tree. For any given Boolean expression, you can draw the binary decision tree. That binary decision tree can be converted to binary decision diagram, a reduced binary decision diagram, or reduced ordered binary decision diagram. How we can reduce it? How we can convert the binary decision diagram to binary decision tree to binary decision diagram is either following the rules. If we follow the rules, there are 3 rules. Okay. If we follow the rules for the given any given Boolean expression, first we will draw the binary decision tree, and rules one by one we will apply on the binary decision tree. And finally, when we complete applying the third rule, the binary decision tree will be totally now converted into reduced ordered binary decision diagram. This is first method. Second method, for any given Boolean diagram, for any given Boolean expression, using the Shannon's expansion method, you have to follow that procedure. Consider that expression, take the first variable in that expression, assign it to or to it, and this procedure first we need to follow if it is using Shannon's expansion method. So we have to use this, and as per the final things we get in this process, we have to draw the diagram. After drawing the diagram also, we need to finally once cross check whether any redundant bridge is present in it. If it is there, redundant node is present in it, and that node need to be removed. And the third method is, for any given Boolean expression, first we have to draw the binary decision tree. And in the binary decision tree, for each and every leaf node, intermediate node, root node, for everything we have to assign some number as per the reduce algorithm. And as per the number, we need to convert the binary decision tree to a binary decision diagram. Is it clear, students? These are the 3 methods we were discussing for almost 4 to 5 hours. Is this clear? Now, once again, I will explain you the reduce. Otherwise, the basic difference, what are the basic steps? Is it clear for everyone?
Yes, ma'am.
So now, today, let us go through. Once again, I'll explain you this reduce algorithm. Okay. Around 20 members have not joined the class. Let me see. Okay. So yesterday we took the expression f is equal to AC plus BC. A, B, C, 3 variables are there. Okay. So based on that, first we have to draw the binary decision tree. Excuse me. So I took first variable A, then B twice, C 4 times, then 8 leaf nodes. A, B, C, 3 variables. So totally 2 power 3, 8 leaf nodes. So 8 leaf nodes. So first we have drawn the binary decision tree. So inside the leaf nodes, the values are filled as per the truth table of this Boolean expression. Next, as per reduce algorithm, the next step what we have to do is we have to give a number for each and every leaf node, intermediate node, and root node. But the order in which we have to give the number is we have to start with the leaf node. So all in each and every leaf node, there will be a value specified in it. So based on that value, the number is given. Suppose in the leaf node, the value is 0 means the number for that leaf node also will be 0. If the value in the leaf node is 1, then the number for that leaf node is also 1. So based on that, the numbers are given for the leaf node. After giving the numbers to the leaf node, we have to move on to the next higher level. The next higher level in this binary decision diagram, we have C. So if we look at the first C, to assign a number for this first intermediate node C, which is present at the left hand side, we need to look at the numbers of its leaf nodes. Leaf nodes numbers are same. If the number is same, the same number I have to assign it to this intermediate node also. So assigned 0. Next to see, leaf nodes have the values which are different. If it is different, look at the value which is highest, and that value plus 1 will be the number for this particular intermediate node. So here 0 and 1. 1 is the highest. So 1 plus 1, 2. So 2 is the number I've assigned to this intermediate node C. Next, same way for this node also 2, this node also 2. Now move on to the next higher level B. To the left hand side B, the two nodes under which, if you see, one is 0, other one is 2. The values are different. Immediate branches you have to see. Okay, when you give a number for B, you have to look at these two C. So this value is 0, this value is 2, the highest, so 2 plus 1, 3. If you look at the right hand side B, we have 2 and 2. The numbers are same, so same number I need to assign. Coming to the root node A, 3 and 2. Highest is 3. The values are different. So 3 plus 1, 4. So this is how you have to assign the numbers to this binary decision tree for all the nodes present in binary decision tree. After giving the numbers, the next step we have to look into those numbers as a group of 3. That means node and it is 2 branches. Like that we need to check. We need to check it from the lowest. If you look at the lowest, we have to start with C's. C and its branches. C and its branches. Like that I need to check. C and its branches, if I see, this all the 3 nodes have the value 0. That means they come under the category of redundant node. They come under the category of redundant node. If it is a redundant node, you already know this node will be removed and 2 output lines will be removed. And in this case, 2 output lines will be removed and the 2 nodes below that output line, one is retained, one is removed. When we use the reduce algorithm, if you find anywhere the numbers are all same or for all the 3, what you guys have to do is the main node you have to remove and the 2 output nodes, lines, 0 line and 1 line you need to remove, and the branch, the bottom one you retain, one you remove. So in that case, for this B, this input line will retain and any one of this leaf node will be retained. So that is for this B, the input node, this dashed line is retained and any one of this leaf node is needed, I have directly connected. Coming to the other side, this is 201, 201, 201. So you will decide now, all patterns are same, so you can have any one. Next little up if you go and see, here 222. In this case also it is a category of a redundant node. So this B we need to remove. This dashed line and the solid line we need to remove. This solid line I need to connect to either this C or this C. Any one I need to retain. Okay. So when we follow this procedure, finally we will get this. Maybe we look into another example. F is equal to AB plus BC plus AC. There are 3 variables, A, B, C, and 8 leaf nodes. You tell me the values. I think this problem you have already done, right? Anybody have written the truth table for this? I asked you to solve this problem using Shannon's. I don't think so. You might have written the truth table, correct?
We've written it.
If you have written the truth table for this expression, can anyone tell me what are the values I need? What is the first one?
0, ma'am.
Ah.
Second one is 0.
Hmm.
Third one is also 0.
Hmm.
Fourth one is 1.
Hmm.
Fifth one is 0.
Hmm.
Sixth one,
Okay.
seventh also 1, eighth also 1.
Okay. Samhita ready? Samhita,
Yes, ma'am.
can you tell me the number for this leaf node, leftmost leaf node? What will be the number? Yesterday you were not there.
Yesterday I was there, ma'am.
Then tell me what will, even now I explained, just
0,
now
ma'am.
0. Next, Akash ready?
Yes, ma'am.
For the second one, what is the number? Second leaf node?
Hash 0.
0. Okay. Next, Sai Krishna, third leaf node. Sai Krishna.
Yes, ma'am. Yes, ma'am. 0, ma'am.
0. Fourth leaf node.
0, ma'am.
Fourth leaf node also 0.
1, ma'am.
Here it is written 0. I want to, this is all just I copied it. Now I need to solve it now.
Okay, 1, ma'am. 1, ma'am.
Okay. DV and Vamsi Krishna.
Yes, ma'am.
What is the next one?
0, ma'am.
Next, all the three.
1, 1, 1, 1.
Okay. Next is for Kirti Reddy. Kirti Reddy.
Yes, ma'am.
For this C, leftmost C, what will be the value? This C. Number?
0.
0. Okay. Next, Gautam Subhas.
2, ma'am.
Okay. Sivanath Nikhil.
2, ma'am. Hash 2.
Huh?
2, ma'am. Hash 2.
How much Sivanath Nikhil for this C?
2, ma'am.
Okay. Vamsi Krishna.
Yes, ma'am.
What is the last one? Chala Vamsi Krishna.
2, ma'am.
Okay. This also 2. Check it properly. The last C. Last C. What it? How we have? How you told to check it out? How we are entering this value? First, you tell me that, Vamsi Krishna. Vamsi Krishna.
1, ma'am. 1, ma'am. 1, ma'am. Both are
1 1. Both are same. So 1. Next, Chava Nikhil. Nikhil, Chava Nikhil. Rani Namrata left. Nikhil. Manish.
Ma'am, it's 3.
It's 3. Okay. Then Bharat.
It's 3, ma'am.
Okay. Meher.
3, ma'am. The final one,
Oh,
A.
okay. Okay. 3. Now Gautam.
Yes, ma'am.
What I can do now? Next.
Here for first C, all are 0, ma'am.
So
So you can directly connect that B dotted line to 110, ma'am.
any 10?
Yes, ma'am.
Okay, let me do that first. What I have done, is it right now? Any 10 have connected, is it right, Gautam?
Yes, ma'am.
Okay. Srinavya, and what else can be done here? Srinavya, what else can be done now? The remaining pattern.
Ma'am, I'm doing it.
Look at the diagram and tell me. I will do here. What else can be done here? Manaswini. Then Navya is not listening to the class. Manaswini. G. Manaswini. Dinesh.
Ma'am.
What else I can do now?
Ma'am, we can connect to that to first 0, ma'am. Like that second C one, C part left one.
I didn't understand, Pa. What you are saying?
For that 0, we can connect, ma'am, second C part.
This 0, to here,
Yes.
No, here you see 201. 201. Do I need this pattern twice?
No, ma'am, no. Okay. Same pattern. Yes. No, ma'am. Once it's
So
sufficient.
what we can do? One is enough, no?
Once not
Shall I
enough.
now? So shall I make only one now? Remaining,
Yes,
shall I remove?
okay, ma'am. Yes, ma'am. One enough, ma'am.
One enough. I will remove. So what I have to do? This I have to connect it here. Okay,
Yes, ma'am. Yes, ma'am.
Anything can be done with this?
I think three ones.
So all
we
are
can connect single one.
We can connect to single one. So I will remove this. Others, please do in your notebook. Anything else can be done now? Next one, maybe. Thank you, Dinesh. Durgakar.
Yes.
Durgakar.
Yes, ma'am.
Can you tell what else can I do here? Do I need this many leaf nodes? Or I need only two leaf node, one with a 0 and one with 1?
We need 2 leaf nodes, ma'am. One with 0 and one with 1.
So can I remove?
Yes, ma'am.
So is this right now? Okay. Anything else can be done here?
No, ma'am.
No, any redundant node is there? What is redundant node? What is redundant node?
When single input comes, two outputs will go to the same node.
Good. So you are listening to the class. So there is no redundant node. Whether we got the same answer when we solved this expression using Shannon's expansion method. Others, anybody else can tell. Thank you, Durgakar.
Okay, ma'am.
Gayatri, you submitted yesterday, right? Did you get the same answer, Gayatri? Gayatri? Gayatri. Gayatri. Nikita. A section, Nikita.
Yes, ma'am.
Nikita, did you people get the same answer? Because same
Ma'am, I'm to see the skill.
No, you people solved this expression using Shannon's expansion method. Did you receive the same final ROBDD?
Yes, ma'am.
Okay. Fine. Next.
Ma'am,
Next.
excuse me, ma'am. Ma'am,
Yeah.
one doubt, ma'am. Ma'am,
Yeah.
can you go, ma'am? Here, that right side B1, can we remove it, ma'am?
Ma'am.
Right side B, yeah.
Yes,
Ma'am.
ma'am. We
Yeah.
can remove it, no, ma'am.
In what way?
Ma'am, the
One by
A,
one.
B,
Wait. Tell me.
ma'am, all the three has 3, 3, 3, no, ma'am. Can't be connected to one B, ma'am.
Yes,
Okay,
ma'am.
in
Even
that way
same
you are
thing.
telling.
Yes, ma'am.
Yeah, we can do it. All the three are connected. No. Now, if I this it's not possible. See, if I remove this starting node, I should have only one. Remember, students, starting I should have only one. At the top, I should have only one node. Suppose if I'm removing this, if I'm removing this A, I have
No,
to
ma'am.
remove this.
We are saying to remove B, ma'am, not A.
No, B we cannot remove. B pattern is B one input and both the outputs are going to two different nodes. And here B pattern is one input, both the outputs are going to two different nodes. So we cannot remove B. That's for 100%. Okay. If I see these three are only coming into that same value, 3, 3, 3. But the problem is, so if I say, I told you already, if the same numbers are same, then it is a category of a redundant node. Okay. So in this case, I need to remove this A and I have to remove this output and this output line. Then my diagram will be having two B's. So in a binary decision diagram, I cannot have two starting nodes. I should have always only one start. So this cannot be removed. That's why I am asking you whether we received the same diagram when we solved this using Shannon's expansion.
Yes, ma'am. Same diagram only, ma'am.
Yes, ma'am. Same diagram only we got.
Then this is right. We cannot remove it. Reason I'm telling, even though this is 3, it comes under the category of redundant node. If I consider this as a redundant node, I need to remove A, I need to remove this dashed line, and I need to remove the solid line. If I remove the binary decision, final diagram will be like starting with the two B's at two different sides. This is not a binary decision diagram. In any binary decision diagram, remember that the starting point should be only one. There should not be two starting points. So that for that reason, we cannot remove this. Any other doubt? Any other doubt, students? Shall we solve one more problem? Shall we move on to the next problem? Shall I?
Yes, ma'am.
Yes, ma'am.
So next expression, I took F is equal to A, B, C, D. Okay. This is the first expression we solved. Okay. So now, Virendra Sai, I've already drawn A, B, C, D, but roughly I have drawn. I didn't, the values are all wrong. I need to update it now. Virendra Sai. Virendra Sai. What is the number for this leaf node? Leftmost leaf node, what is the number? No, before that, tell me these values you must be having in your notebook.
I think
Leaf
that
node
problem
value.
I have not done.
You have not done. Haris? Hari,
I'm not done.
you
I'm
have
doing,
not
ma'am.
done. Very good, very good. Prashant,
No.
Prashant, have you done at least? No. Prashant, I don't know where this Prashant went. Prashant, have you at least done this problem in your notebook?
Ma'am,
Have you done? Have you solved this problem in your notebook?
doing
Which is
ma'am.
there in this doing? Anybody from C section? I want the answer now. Who can answer? Give me the values. Anyone from C section only? I want. No.
Ma'am, first one 0, ma'am.
Who's this? Nagasai Kumar. Okay. First one 0. Second one
0.
Okay.
Third one 0. Fourth one 1.
Okay.
Fifth one 0. Sixth one 0. 1 minute, ma'am. I'm doing.
Yeah.
Ma'am, seventh one 0.
Seventh one 0. Then
Eighth one 1. Again 0 0 1, ma'am. 0 0 0 1. Same.
0
3.
0 0 1. Okay.
Then all ones, ma'am. Last one.
All 4 ones.
Yes, ma'am.
Who's this?
Pranit, ma'am.
Pranit. Okay, good. Okay. Now B section. Starting from the below, I'll go. Now, once I want C section. Venkata Manoj Kumar. C section, right?
Ma'am.
Venkata Manoj Kumar.
Yes, ma'am. Yes, ma'am.
Manoj, tell me, Manoj, what will be the value here for all leaf nodes from starting from left?
Ma'am, one
Ma'am,
second.
is
The
this?
last
Yeah.
is one, ma'am. Sorry. The last 5 it is ones, ma'am.
1, 2, 3, 4. Yeah, 5. Last 5 ones I have written.
Okay, ma'am. Okay. Sorry, ma'am.
Okay. Then whom I was asking? Manoj, tell me.
Yes, ma'am. Has 0, ma'am. Has
Next
0, has 0, has 0.
has the fourth one also has 0.
No, ma'am. Fourth one has 1, ma'am.
Then?
And the next 3 are hash zeros, ma'am. And the 8th one is hash 1, ma'am. And the next 3 are hash zeros. And the last 5 are hash 1s, ma'am.
Okay, Manoj. Thank you. Muhammad, Sarfaraz is there? Naveen Kumar, Pasam Naveen Kumar. Naveen Kumar.
Ma'am?
Who's this?
Ma'am, this is Kuber, ma'am.
Yeah, Kuber. Any
Ma'am,
doubt?
that's second day, ma'am. That last two, we are getting ash 0 and ash 1 now, ma'am.
Which one? Last two left or right?
From starting, ma'am. From starting.
Starting, first 2 are 0. Which one you're telling?
Last, ash 0 and ash 1 now, ma'am.
Which D you tell? Which D?
Second D.
Second D, 0 and 1. Yeah, correct.
Then in that top one, we have to get ash 2 now, maximum plus 1.
No, I didn't enter this. As of now, I've solved only leaf node.
Okay.
I'm resolving this problem, Kuber. Only leaf node I have updated. These are all I ran. For solving, I made the things easy and prepared the slides already. Okay?
Okay.
Now we'll solve. Your friends will help me now. Sumant or Naveen. Sindhu Teja. Nobody is responding. Sindhu Teja, Sumant, Naveen. Sindhu Teja, tell me, for this first D, what will be the value?
0, ma'am.
Next D?
1, ma'am. 2,
1,
2, ma'am.
Okay, next Sai Pranati. Sai Pranati, third D. Sindhu, you can mute yourself. Sai Pranati. Geeta is where? Sai Pranati, tell me. Yeah, tell me.
0, ma'am.
0. Fourth D.
Fourth D, 2, ma'am.
2. Okay. Geeta is where?
Ma'am.
Fifth
Fifth
D.
D is 0, ma'am.
Sixth D.
2, ma'am.
Okay. Next is for Parvati.
Ma'am.
Last 2 Ds.
Ma'am.
Last 2 Ds.
Last 2 Ds, #1, #1.
#1. Okay, Nikita.
Yes, ma'am.
First C, left hand side, first C.
3.
3. Okay. Next, Nikhileswar. Nikhileswar, second, left hand side C. Nikhileswar. Priyanka.
Yes, ma'am.
What is this value?
C is 3.
Okay. Next, Sai Rohit. Sai Rohit. Manasa.
Yes, ma'am.
Manasa, what is the third C?
3, ma'am.
3. Okay. Next, Raymond Pavan. Raymond Pavan. Ujjwala.
Yes, ma'am.
Fourth
1.
C.
1.
1. Okay. Next, Varun. 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 Not responding. Sarfaraz. Achilles. Achilles is showing on hold. Where are you, Achilles? Where you are in another call? Achilles.
Ma'am.
Achilles, tell me.
Ma'am.
First B, what will be the value? Left hand side B. The branches are 3 and 3. So what will be this B? Value. If the two branches values are same, what will
3,
be this?
ma'am.
3. Good. Kausik, for the right hand side B, you tell me the value, Kausik. Sai Kausik.
4, ma'am.
4. Okay. Sai Karthik, for the root node. Sai Karthik. Karthik Sai. Karthik Sai. Manoj Kumar, B section Manoj Kumar.
Yes, ma'am.
And what will be the value for the root node now?
5, ma'am. #5.
Okay, next Sumalata. How I can modify this now? Tell me. Start from left hand side, the bottom one. Sumalata. Sumalata not responding. Mahima.
Yes, ma'am.
Can you tell me what I can do?
Both are different now, ma'am.
Which one?
D and D.
No, if I look at this D, all are same.
Same. So we can remove
So
and
can I
connect
remove?
it to 1.
1 or 0?
1 0, ma'am.
Any
Single
1 0.
Any 1 0.
Okay, let me do that. Next, okay, Mahima. Next, Karthik Sai. Not responding. Ganesh. Ganesh.
Yes, ma'am.
What else I can do now?
Ma'am,
2
same
0
pattern.
1 2 0 1 2 0 1 I have here.
Yes, ma'am. Make it a
Can
single.
I remove? I can make it single. I will remove this. Others, please, you also modify and redraw the diagram step by step. Madhu?
Yes, ma'am.
What I have to do next after I complete this?
Ma'am, we have all 0 0 0 D 0, and then I can remove
Where?
that and come. Here.
0 0 0 0 0 0. These two you are telling.
Yes, ma'am.
Okay, okay, Madhu. I'll do it. Okay, 1 0 I need to retain here. So what I have done wrong? Which D I need to remove? I think I made a mistake. It should be here. This D I need to remove. Yeah. Next to Madhu, Sai Sriram. Sai Sriram. Sai Sriram. Anything else can be done here? Fast. Okay, Kuber, what I have to do next?
Ma'am, we can combine both the ones, ma'am. Last 2 days.
Okay, so from C, 0, 1, 1, I can send to 2 only one leaf node 1, correct?
Yes, ma'am.
So this 0 or 1, I will take it here. Okay, next term, next to Kuber. Meghna. Meghna.
Yes, ma'am.
What else I can do here?
C is a redundant node.
C is a redundant node. The C,
Yes,
left, right
ma'am.
and C,
Yes, ma'am.
So what I have to do? I have to remove the C and which output lines or input line?
Straight line from B, ma'am. Solid line from B.
Okay. Okay, Meghna. Next term. Lohit.
Yes, ma'am.
What else I can do now?
I mean, here between two C's, 3030, no, ma'am. We can connect them to single zero.
Okay.
And here that last, I mean, the leftmost B can be directly given to 0.
1 minute, 1 minute. Let me do this first. This zeros I have to connect it to only 1 0. That's what, right?
Yes, ma'am.
So from here, I have to connect it here, correct? And from this C also, I'll connect it here.
Yes, ma'am.
Correct?
Yes, ma'am.
Now what else you told?
The leftmost B can be directly given to 0.
Leftmost B directly given to 0. Wow.
That 0 line can be directly given to 0, no, ma'am.
Are you talking about this pattern? 3 3
No,
3?
no, ma'am. No, ma'am. It's wrong. It's wrong. No.
Okay. Next, Krishna Satvik. Krishna Satvik. Vinita.
Yes, ma'am.
What else can be done here? For me, I felt like these three are same.
Yes,
correct? Can we remove
connect
this?
only one C, ma'am.
We can remove this. Connect to only one C, and this C, if you look, C when it is 0 going to 0, when it is 1 going to D. This C when it is 0 going to 0, when it is 1 it is going to D. So this C also I can remove. This should be there. This I need to remove. Okay. Anything else? Anything else, students, we can do here?
We can remove third C also, ma'am. Like connecting to
Okay.
second B. Because he's
Okay.
also connecting to 0 and D.
Yeah, correct. Third C also we can remove. Okay. Anything else? Anything else, students?
No,
That's
ma'am,
all.
it's
Huh?
fine. That's all, ma'am.
That's all. Huh? How many leaf nodes are there? You see, have to made common, right?
Okay, okay, ma'am.
This has to be connected here. This need to. Yeah, done. Correct. Is this right? Whether
Yes,
we
ma'am.
got the same answer when
Yes,
we
ma'am.
solved it initially? Yeah. Is it clear now? See, I have made a totally mess in the slide, but when you people draw it, like one by one, I removed. If you could find 2-3 changes, maybe when you redraw the diagram second time or third time, 2-3 changes together also you can do. First, you are drawing the binary decision diagram, and in the you could find like 2-3 things you can make modify. At a stretch, one more time you draw the diagram with those 2-3 changes. Then you once again look into it. If you find that still more, you one more diagram you have to draw. At least 3 or 4 steps you will get for the bigger one. For the smaller one, maybe 3 times totally you may need to draw. Is it clear how you have to represent the answers for this problem? So totally for all the 3 methods, we have solved f is equal to AB plus CD, f is equal to AB plus BC plus AC. Next, f is equal to AC plus BC. We have solved in using all the 3 methods. This is there, no, f is equal to a plus c plus this last expression. This we have solved only using which method? Rules or Shannon's expansion or reduce algorithm? Tell me the last expression.
Rules method.
Rules, ma'am. We are using of rules, ma'am.
Only rules we have done. So next week class, next week you have an exam. So after the exam or something, I want you to solve this problem using reduce algorithm and the other one is what do you say? Shannon's expansion.
Shannon.
Okay, solve this final expression. Still more, any expression you people can take it. Any expression you take, try to solve it using all the three methods. I will not further discuss about all these three methods. After the midterm, I'll start with the still one more algorithm we need to go through. Apply algorithm. Okay, so that I will look into. After that, I will move on to the next topics. Okay, so today 1 o'clock, please join. Everyone need to be connected through Teams, and you have to log in your AEMS for the mock test today afternoon 1 o'clock. Teams, you have to switch on your videos, so be properly dressed. Okay.
Okay.
1 o'clock, everyone, please connect through Teams and log into your AEMS. I have already sent the invite for the mock test. I'll meet you at 1 o'clock today.
Ma'am?
Okay? Yeah.
Ma'am, I have one doubt, ma'am. Ma'am, we are switching on our video, but due to some network issue, for you or for me, you can't see the video. Then what is the issue, ma'am?
No, we need to see, actually speaking, now, today,
No.
what we are, no, I'm just telling you, see, today, I'm only monitoring 88, I cannot monitor. But next week exam, 2-3 faculties are allocated. We will split you among us. And we will monitor.
But actually, yesterday's class also, we can see his camera on, but you can't see, no, ma'am.
No, there is some modes settings. All together mode or something. I don't know. For me, that option I could not see, but other faculties told me. There are together mode, it seems. If I click that, I can see many people's pick. At least if I am not able to see many people, we will randomly check your videos. One, we will connect and we will check your videos during the exam.
Okay.
I'm once again, I'm telling you guys, 1 minute. For this end semester, testing end semester, you have to be very